Okay, we'll start about the APIs. And the topic is component-based APIs, which is used for the versioning and for the distributed application. First of all, we'll get started by the API. API is a application program interface, which is a connection between the two computers or two applications who would like to talk to each other or pass any communication. An API is defined as a standard interface for invoking a specified set of functionality. We can example of an API, the generic security services, that is GSS. It's an API which defines the standard functions for verifying identity of a communicating parties, encrypting the messages, and so forth. And this is an example of an API. And the component based development using an API is, that is a component based software engineering, which comes under this, that is CBS. It's an approach to software development that relies on the reuse of entities called software components. It's emerged from the failure of object oriented development to support effective reuse. A single object class are too detailed and specific. The components are more abstract than class objects. In the component based developments, they are more efficient than the object classes, like in the OOPS, and they can be considered to be a standalone service providers. They can exist as a standalone entities, so they can work as a alone without any further supports. They can exist as a component based development can exist as standalone entities. And the software techniques have been developed to facilitate the software reuse. The functionality are encapsulated inside the components with a goal of limiting the program errors due to implicit interaction between these components. The late binding of components allows implementation to be chosen at the runtime by increasing the opportunities of the reuser. So by developing the strengths of this component software, a component based operating system application program interface, that is API, can be ready-made to weakens of the current monolithic procedure of APIs. Current APIs are typically very rigid. They cannot be modified without jeopardizing the legacy applications. Their rigidity results in both in API complexity and support code. Also, API focuses primarily on the single host machine. So this can be overcome by using this component based OS and APIs. They lack the and old APIs. They lack the ability to name and manipulate the OS resources on remote machines. So an API is constructed entirely of the components, can leverage the version management and distributed computing facilities. The version management can be used to identify legacy APIs, which can be dynamically loaded. OS resources modeled as components can be instantiated on remote machines and then can be manipulated as a natural access. So this a component based API provides an more efficiency and more compatibility to use than the other type of this. And we'll be moving on to the component object model. Component object model in the component based OS softwares. COM was developed by the Microsoft, as we are very familiar with that, uh, to address the need for cross application interaction. As the word evolved, the distributed COM DCOM extensions were introduced to support the distributing computing. COM provides a language independence by employing a binary standard. Computing interfaces are implemented as a table of the function pointers, which are V tables, because they are minimized from the format of a C++ virtual function tables. A reference to the component instances are referred to an instant pointers. We use pointers in the C++. We'll be using in the computer object model. These are actually double indirect pointers to be reachable. The extra level of indirection is provided as an implementation convenience. For example, an implementation can be attach useful information to the interface pointers, information that will be shared by the all references to the interfaces. So COM maintains a strict separation between the component interface and the implementation. Okay, COM divides both the implementation and the interface. The COM is facts nothing but about the implementation, not only about these interfaces. Interface can be defined through a single inheritance. COM components can be implemented multiple inheritances regardlessly of inheritance hierarchy. So COM components possess this inheritance property, so they can implement multiple components, multiple interfaces, and based upon the inheritance hierarchy. This provides a much same power as the multiple interface inheritance, which is possessed by the component-based object model COM. Is the flowchart, the application, proxy, and the network connection between the two components, that is the component instance and the application. The COP implementation. In this section, we describe about the COP implementation. First, the subsection describes how the monolithic Win32 API was factorized into a set of interfaces. The second subsection then discuss the COP runtime subsystem, including the support of versioning based APIs and distributed applications, which is used based upon the APIs. We'll be saying, and the factorizing of a monolithic API. The first step in constructing a component based API is to split. The first step in the component APIs is to split them. The splitting is done by the factor. The monolithic API is a set of interfaces. After factoring, the entire API should be modeled by a set of interfaces with the individual and independent OS resources and services modeled by independent interfaces. And then the flowchart of the final factorization, which is the first step of making an component based API. Yeah. Versioning. Versioning using a component-based API, COP and others' main advantage over modern OS APIs, its versioning capabilities. Their capabilities follow directly from OA factory strategy, COM's robust versioning mechanism. They describe about the published COM interfaces are mutable and they named by the globally unique ID. The clients can request a specific interfaces, so the user can be decide to know to take a interface which he likes. So this provides a greater compatibility for the user to access anything or to do heavy operations on the computer, and can be assured of a desired call syntax and semantics. Conclusion of these component based APIs of versioning and the distributed applications is the software provides an excellent this component based software provides an excellent support for the evolutionary department of the software and for distributed computing. By basing an OS API and components, a system can gain considerable leverage into two areas. An OS can export different versions of API, allowing API to be modified without jeopardizing legacy applications. Instead, the support for legacy applications can be dynamically loaded. So, is the end of the component based APIs versioning and distributed applications. Let's get start with the conclusion and future works of this component based software. And the main contribution of this work is to propose an incremental approach for distributed component based software development that integrates several mechanisms guiding the software engineer as much as development as in the use of components of problem domain. The integration of mechanism in the MV keys tool makes possible the development of the components and applications in a distributed platform. Although the mechanism exists in a literature, there still exists a void of methods and tools that integrates them and assist software engineer in the distributed component-based software development. The usefulness of an incremental approach is to aid distributed component-based software development. This quantitative analysis realized a part of a study and provide evidence that the subjects who made use of this incremental approach obtained the better results than those they used the other methods. In future works, the two directions are being searched for integration in this approach. The utilization of the aspect-oriented program, that is AOP, to treat distributed and database persistence, as well as insertion of the other conditions like concurrency control and security. The second directions come from COTS user.
Lastly, we intend to gather the experience with the users of the approach and perform future experiments to verify its approach can be successfully applied to the larger projects and to investigate distributed component performance and finally to explore the utilization. And that's it, it's end of the session.